We have multiplication of two binomials. Why? Because in the first parenthesis we have two terms and in the second parenthesis we have two terms. How we do this multiplication? We have to multiply every term in the first parenthesis by every term in the second parenthesis. So we have to multiply 3mn squared by this whole expression. So let me write this. 3mn squared times 3mn squared minus 2a cubed y, and we have to multiply 2a cubed y times this whole expression in the parentheses. So it will be 2a cubed y times 3mn squared minus 2a cubed y. This is one way, little longer, and the second way is if you see that we have 3mn squared and 3mn squared, 2a cubed y, 2a cubed, only the sign is different. So we have here difference of two perfect squares formula. You can use this or you can do step by step. So first let me do this step by step, and next we will use this formula. So you will see how shorter it will be if you memorize a few formulas. So this is equal. Now we have to use distributive law of multiplication. We have to multiply every term in the parentheses by 3mn squared. So we have 3mn squared times 3mn squared. Next, we have positive times negative, so it will be negative. When we don't have sign, it's always positive. So we have 3mn squared times 2a cubed y. And the same we have to do with the second expression. We have to distribute 2a cubed y over each term in the binomial. So we will have plus, because positive and positive, so it will be positive, 2a cubed y times 3mn squared. And now positive times negative will be negative. And we have 2a cubed y times 2a cubed y. So this is equal. We have to multiply the numbers and next the same variables by the same variables. So 3 times 3 is 9. We have m times m, the same base. So we copy the base, and when we don't have exponent, it's always invisible 1. So 1 plus 1 is 2. M times m is m squared. Next we have n squared times n squared. So we copy the base n and we have to add exponents. 2 plus 2 is 4. This we can use only when we have multiplication. We have multiplication between these two expressions. Minus, and again, first we multiply the numbers. 3 times 2 is 6. And next, the same variable with the same variable. But here we don't have the same variables, so we will put these variables in the alphabetic order. So first will be a cubed, next will be m, n squared, and we have y, plus number times number. 2 times 3 is 6. And next we have different variables, so we will put them in the alphabetic order. First a cubed, next m, n squared, at the end y. And we have minus 2 times 2 give me 4, and again the same variable with the same variable, so a cubed times a cubed will copy the base a, and we have to add exponent. 3 plus 3 is 6. And y times y, so we copy the base and we have to add exponents. When we don't have exponents, it's always invisible 1. So 1 plus 1 is 2. So now we have to combine the like terms. We have negative 6a cubed mn squared y and positive 6a cubed mn squared y. So negative 6 and this whole expression, and positive 6 and this whole expression, the same expression we have after 6. So this whole expression we can cancel out. This will be 0. So we have only 9m squared n to 4th power minus 4a to 6th power y squared. This is one way to solve this problem. On another, like I said, we can use formula difference of two perfect squares. Let me remind you of this formula. When we have a minus or plus b, doesn't matter what we will put first, times a minus b, this is equal a squared minus b squared. In our example, a is equal 3mn squared and b is equal 2a cube y. So now we can use just this formula. This whole expression is equal to these two terms. We have to take to second power first expression and the second, and the sign between these two expressions is negative. So let me copy again our example. We have 3mn 2a cube y times 3mn squared minus 2a cube y. So this is equal, we just will use this formula, so it will be first term to second power, so 3mn squared have to take to second power. Next we have to keep negative sign, and we have 2a cube y to second power. So this is equal, we have to take to second power every term in parentheses. We have multiplication here. So 3 to second power, m to second power, and n squared to second power. The same will be with the second term. So we will have 2 to second power, a cube to second power, and y to second power. So this is equal, 3 to second power is 9. Next we have m squared, n to second power, so we have to multiply the powers. 2 times 2 is 4, so n is to 4th power, minus 2 to second power is 4, a cubed to second power. We copy the base and we have to multiply the powers, exponents. 3 times 2 is 6, and we have y squared. So we see that we got exactly the same expression which we got when we multiply every expression in the first parenthesis by every expression in the second parenthesis. We got exactly the same result which we got when we use this formula, difference of two perfect squares. So it's a very good idea to memorize this formula. This is my solution.